show that between any two roots of the equation e to the power of x cos x minus equal to 1, this means there exists at least one root of e to the power of x sin x minus 1. Now answer let alpha and beta be the roots. We can frame this equation in a different manner. I mean to say, you can write ex cos x of cos x equal to 1. Let alpha and beta be the roots of this. We can reframe this equation. See, e cos x minus 1 equal to 0. That means you can write like this: cos x divided by e to the power of x. So this will become e to the power minus x equal to 0. Or you can write this as e to the power of minus x minus cos x equal to 0. Consider, wait a minute, consider fx equal to this is the trick actually here, e to the power of minus x cos x minus cos x equal to 0. This is the equation. Now 1, e to the power of minus x and cos x are continuous in closed interval alpha and beta. Number 1 point of the Rolle's theorem, because they are exponential and polynomial trigonometric functions, so they are continuous. They are derivable. E to the power of minus x and cos x are derivable. That means they're differentiable. Derivable in alpha comma beta. This is also in according to the second rule of Rolle's theorem. Third, now f of alpha is 0. F of alpha is 0. Why? Because alpha is a root. That means, look here, e to the power of minus alpha minus cos alpha is equal to 0. This is done. Similarly, f of beta is equal to 0. Why? Beta भी क्यों? If beta is 0 क्यों है? कि beta भी root है, alpha भी root है. इसलिए if alpha भी 0 है, if beta भी root है, implies from here e to the power of minus beta minus cos beta is equal to 0. So the third condition of Rolle's, third condition, f alpha, f beta are equal. Just a minute, let me rewrite this point, very important point. The third point, therefore, f alpha equal to f beta, wait a minute, beta it is, f beta is equal to 0. So all the three conditions, the 1, 2 and 3 conditions are satisfied. Now therefore there exists a C belonging to alpha comma beta, or let's write it gamma. Between your alpha and beta such that f dash gamma is 0. Now what is fx? What did you write fx as? You wrote fx as e to the power of minus x minus cos x, and this was 0. Take f dash x minus e to the power of x plus sin x equal to 0, because minus of, see, look here, this is derivative of this, or this is, sorry, wait a minute, derivative of this is minus e to the power of minus x minus sin x, so is equal to 0. This gives me e to the power of minus e to the power of minus x This gives me minus e to the power of minus x plus sine x equal to 0, right? But here it is saying f dash gamma is 0. This is f dash x. Put gamma in place of x. Gamma लिख दो place x की जगह पे. So now f dash gamma is 0 implies minus e to the power of gamma minus gamma, wait, e to the power of minus gamma plus sine gamma equal to 0. That's right. Now divide. Now this can be written as minus 1 upon e gamma plus sine gamma equal to 0. That's right. Now this can be written as minus 1 plus, take an LCM. LCM ले लो. Sine gamma equal to 0. That means this implies e to the power of gamma sine gamma. This implies minus 1 is 0 and gamma is any number between alpha and beta. Any arbitrary number. We can call it x. No problem. So, so, so gamma is a root of, because e gamma sine gamma minus 1 is 0. So gamma, because of gamma, this quantity is becoming 0. This whole quantity is becoming 0. Some arbitrary number it is here in between. You can write x also, no problem. That is gamma is any number between alpha and beta. Gamma कोई number है alpha beta के बीच में जो कि इस function को, इस पूरे function को 0 कर रहा है. So gamma is the root of किसका? E to the power of x sine x minus 1. So gamma is the root of e to the power of x sine x minus 1, because e to the power of gamma sine gamma minus 1 is becoming 0. So gamma is the root. Now let us take another question. Sorry, don't know from where it has come. Now this question. Now we have, if fx is a polynomial, let's write down the question. If fx is a polynomial and k belong to R, the real numbers, prove that between any 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 two real roots of fx there is a root of f dash x plus k fx equal to 0, where this k is this k. बोलना क्या चाह रहा है, एक पॉलिनोमियल है और कोई नंबर k है, रियल नंबर. कोई भी दो रियल रूट हो एफ एक्स का, तो एक रूट इसका मिलेगा उन दोनों रूट्स के बीच में, जैसे पहले वाला प्रॉब्लम किया था. The way I did the other problem, between two roots I'll find another root. Now to do this type of problem, when you are seeing this type of an equation, you do something in the rough. I'll tell you what to do. This is the best way to do it. See, f dash x, take that k to be any real number, let it be positive, negative, whatever. Let us consider k is minus 1. Suppose I'm doing it in the rough. This you don't have to show. Don't show this. This is plus fx here. So f dash fx is something 1 or something. Yes, plus 1. So this becomes log fx is some constant x. So fx becomes e to the power of x type of a function. That's why. So what you do is that you do it from this. This is the trick. You to do this. You don't have to show this trick. ये trick दिखाना नहीं होता है. करना क्या है? Look again. you have this, you have to show this now. So the only way to find the function, because I don't know what the function is, I don't, मुझे मालूम नहीं फंक्शन क्या है, मैं इसका हेल्प लूंगा। तो मैं रफ में करूंगा, मैं एफ डैश एक्स को लिखूंगा, इसको के को -1 ले लूंगा, के -1 से यहाँ पे +1 हो जाएगा। इफ आई टेक के इक्वल टू -1, दिस विल बिकम +1, put f dash x away upon fx equal to 1. So this is, if you take the integration, if you integrate both sides, this will become log fx plus is equal to x, something like that, dx or something like that. So fx will be of this form, e to the power of x form. So, and let us take this number k, whatever it may, it is a k number, kx. So what you do is that, you rub all this and take a function. This is the way you have to do it. You have to do this function, this question in this manner. These are special type of questions. So let gx be e to the power of kx, be that function, and into fx. You have to take this way, the function. How to take the function is this way. Okay. Now, once you've taken this function, let a and b be two roots of fx, as they have told you. Any two roots of fx. That means, that is, f of a is 0 and f of b is also 0. That means this is there. Now gx is this type of a function and fx is a polynomial. In the question it is given fx is a polynomial. So 1 point. Gx is continuous on closed interval ab. Second, this is a exponential function, this is a polynomial function, so they are differentiable. Is derivable on open interval ab, on open interval ab. Now the third point, that is g of a. G of a is e to the power of k a f a, and we know f a is 0, so this is 0. And g of b is e to the power of k b f b, and this is also 0 because this is 0. So therefore, g a is equal to g b is equal to 0. The third condition, first, second, third condition of roles are satisfied. First, second, third condition of roles are satisfied. Therefore, now there exists a C between A comma B such that G dash C is equal to 0. What is Gx? Gx is e to the power of kx fx. Take the derivative. First as it is, derivative of the second plus second as it is, derivative of the first, e to the power of kx, and this is equal to, this is the thing, the derivative. Now g dash c is 0. Now g dash c is 0. That means e to the power of, implies e to the power of kc f dash c plus fc k e to the power of kc equal to 0. Take e to the power of kc common on all sides. Take k as c kc e to the power of kc, this e to the power of kc, this e to the power of kc, e to the power of kc common f dash c plus k f c. This is equal to 0. This cannot be 0. So this quantity will be 0 because it's an exponential function. Exponential function is never 0, like this it goes. So never 0. So this only is 0. So f dash c plus k fc is 0. Now c is any arbitrary number between a b. C is any arbitrary number. So c is the root of this equation, and c is also any arbitrary number between this. So this, therefore c is a root of c is between a and b are roots of fx, not of this. C is the root of f dash x plus k fx equal to 0. This is the way you do applied Rolle's theorem here. Now we will do one more very good question. That is one or two more questions we'll do on this. Now the next question is very simple but a very good question. They are saying prove that for any real number lambda belonging to R, any real number, the polynomial the polynomial uh, polynomial polynomial fx equal to x cube plus x plus lambda has exactly one root, has exactly one root. Let us consider this. This is the thing. By contradiction, we'll do it because I will show there are two roots. So first thing, this is a polynomial. Fx is polynomial. Suppose, let us write first suppose, let us, oh sorry, suppose A and B are roots. Then, of course, if and that means f of A is equal to f of B must be 0. That is the point. This is important. We have supposed there are two roots, but I will show there is exactly one root. Now see, fx, number 1 point, is polynomial, hence, and so it is CTS on AB. Second, let me take some more space here. Wait. Let's do it here. 2 fx is a polynomial, so it is derivable. Let me write down. Let me write it down. Polynomial. Wait a minute. Polynomial. So derivable on open interval AB. Now I have already told that f and fb are roots. Third point, fa equal to fb equal to 0. I have told this they are roots. Therefore, there exists a c in open interval AB such that f dash c is equal to 0. Take the derivative of the above function. Now write down the derivative. Fx is given to be as x cube plus x plus lambda. So f dash x. So f dash x is 3x square plus 1. Now they are saying f dash c is 0. So f dash c 0 means 3c square plus 1 equal to 0. Now c is equal to minus, c square is equal to minus 1 by 3. And if I take the under root, if I take the under root of minus 1 by 3, this comes out to be under root 1 by 3 iota. So rather I should write it like this only. Wait. 1 by under root 3 iota, which does not belong to R. There is no real root, which contradicts the fact that this C, the C won't lie between A and B. So C won't lie, does not belong to A and B, a contradiction. Therefore, there cannot be two roots, but exactly one root. So there cannot be two roots, but exactly one root. Now see one thing. C is coming out to be imaginary. C imaginary आ रहा है जो कि real line में नहीं है. C is coming out to be imaginary, which does not belong to R. So C does not belong to A and B. A and B are real roots because we have taken, listen, in this question we have taken Suppose A, B are, I should write real roots because the question says between this, for any lambda belong, the polynomial has exactly one real root. I missed this thing. This is very, very important. This part of the question I missed it. Wait. One real root. This line is very, very important. Real root. So I have taken A and B are roots. I should rather write here. Instead of roots, I should write. Okay, I should write this way. Suppose A and comma B belong to R are the roots, then this thing. Now it's okay. Then I've got between two real numbers here, I've got C, and this C comes out to be imaginary, which is not in between A and B. देखो जो C मुझे मिला है यहाँ पे वो क्या मिला इमेजिनरी, और मैंने ए बी को क्या लिया रखा है रियल रूट्स, और सी भी क्या आना चाहिए था रियल, दो रियल के बीच में इमेजिनरी कहाँ से आ गया. So this C does not belong to this. So there cannot be two real roots. Now let us do one more question. Now the question is of this form that fx is given to you as x cube minus 6x square plus ax plus b. This is already on 1 comma 3. Rolle's theorem is verified. Our Rolle's theorem is verified. Find AB. Find A comma B. This is the thing. मतलब रोल्स थ्योरम वेरीफाइड मतलब रोल के सारे कंडीशन हैं वेरीफाई हो चुके हैं, बस मुझे A and B चाहिए. That means I don't see it is already satisfies all the condition of roles. See, so I have to write f of 1 is equal to f of 3. I have to write this, and now the point is and there is some more part of the question I forgot to write. Find A and B. Find A and B, and the C which lies between A and B is such that is given by C equal to 2 under root 3 plus 1 by under root 3. Then only I can find A and B. Therefore, what is the question saying? There is a polynomial like this, A and B are unknown to me. It satisfies Rolle's theorem. I have to find A and B, where there is a C between A and B, where C is given by this number. Now, already they have told me this. Now, the point is this, and this at f of 1 and at f of 3, the additional condition that needs basically that needs to be told to you is that, which has not been told in the question, I don't know why, that this at 1 and 3, they are the roots. I need to tell this. I need to take this. Additional information missing in the question was, that's why it took me some time to get over this question, that f of 1, or I can say 1 and 3 are the roots of this, or I can say and this 1 and this 3, x equal to 1 and x equal to 3 are the roots of fx. Then only I can solve this problem properly. Now, all the conditional roles are verified. We know the last f of 1 equal to f of 3, and they are roots, therefore 0, as 1 and x equal to 1. Wait a minute. As देखो यहाँ पे ना एक एक्स्ट्रा क्वेश्चन में वो था, मिसिंग था डेटा, वो ये डेटा मिसिंग था. बिना ये I cannot take this equal to 0. बिना roots हुए I cannot take them equal to 0. Role's third says कि this is, they two are same, fine, but Rolle does not say that they are equal to 0. Third condition does not say they are equal to 0. Until and unless I take them as roots, I cannot make them zero. रोल्स के थ्योरम में ये दिस इज ओके, दिस इज द अंडर थर्ड कंडीशन, बट दे आर नॉट, इसको बोला नहीं गया कि इक्वल टू जीरो है, दे आर नॉट इक्वल टू जीरो। मैं इसको जीरो नहीं ले सकता हूँ अगर ये रूट्स नहीं, अगर रूट्स ना हो तो मैं इसको जीरो नहीं ले सकता, रूट्स होना जरूरी है। सो द थर्ड पॉइंट वाज द थर्ड कंडीशन, दिस इंपॉर्टेंट लाइन इज मिसिंग देयर। I just cannot write that they are zero if this line is not there. If this line is there, then only I can write this condition. Otherwise, not. This line was missing there. That's why it took some time for me to get over this question. Now, now see, now things are okay. All conditions satisfied. Find f of 1. F of 1 is what? 1 minus 6. 1 cube minus 6, 1 square plus a into 1 plus b equal to 0. So this will be very simple. 1 minus 6 plus a plus b equal to 0. This will give me a plus b. This will give me a plus b equal to minus 5. Plus 5, sorry. This will give me a plus b equal to 5. This will give me a plus b equal to 5. Equation number 1. Now the third. Now let us find the third one. Now let us find the third one. Third one. Third condition is this f3. f3 is equal to 3 cube, that is 27 minus 9 6 are 54, 9 6 are 54 plus 3a plus b. So this is equal to 0. So you get 3a plus b. 3a plus b is equal to plus 27. This is equation number 2. Fine, that does the job. Now, see one thing. This two you can just solve simultaneously. That would do the job. Even if, see, this line is not that important. That C belongs to this. Is not that important. But this line is important. Wait. This line is important. This x and is the x equal to 1 and these are the roots. Not that important. Because you have to find a and b. Now, 3a plus b equal to 27 and a plus b equal to 5 minus 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 2a equal to 22. A is 11. If a is 11, use this equation. B is minus 6. Now next. The next question is, yes, question, let a naught n plus 1 plus a1 n plus a2 n minus 1 plus so on and so forth a n minus 1 2 plus a n equal to 0. Show that show that uh, show that show show that show that show that there exists at least one real root between, okay, wait, let's write the shortcut, between 0 and 1 such that such that such that a naught x to the power of n, a naught x to the power of n plus a naught x to the power of n, a1 x to the power of n minus 1 plus, let me write it in the next line, wait, such that a naught x to the power of n plus a1 x to the power of n minus 1 plus so and so forth plus an is equal to 0. This is given to me. This whole thing is equal to 0. I have to show that at least one real root lies between 0 and 1 such that this condition is 0. If this condition is 0, I have to show that this condition is 0. So let us define a function fx. Let us define a function capital Fx, some function fx equal to, the trick is, listen one thing, I have to use this to show this. I have to use this to show this. Now, if I take a function a naught n plus 1 x to the power of n plus 1, see what will happen. I'll take a function of this type from here. I'll see the function from here. I'll मैं function यहाँ से बनाऊंगा इस वाले लाइन से, plus a1n x to the power of n up to so and so forth, plus an minus 1 to x square plus an x. This function I will make from here because I have to take the help of this. Now add, because just a minute, let me keep it here. Add between 0 and 1. So add 0, the whole function is 0. Add 0, this whole function is 0 because there is an x here, at the end also there is an x. Now at f1, this is a naught n plus 1, a1n up to so and so forth, an minus 1 by 2. This will become 1 plus an. And this cannot be 0 until unless I use this condition. ये 0 नहीं होगा जब तक मैं ये condition use नहीं करूँगा. This is 0 because of this condition. This whole condition. देखो ये 0 तब तक नहीं होगा, ये पूरा 0 नहीं होगा जब तक ये कंडीशन अप्लाई नहीं करूंगा ऊपर वाला. So this is okay. Wait, let's rub all this. Now this is a polynomial, this is continuous, differentiable, everything. This is polynomial, this is continuous, differentiable and everything. So let's just write it down. Let us just write it down. That this function is 1. Fx is a polynomial, so continuous on 0, 1, close interval. Second, fx is derivable on 0, 1. Okay, sorry, 0, 1 it is. On 0, 1. Now I just told you, अभी दिखा दिया f0 भी 0 है और अभी दिखाया f1 भी 0 है. So that means f0 and f1 are same. So all the three conditions of roles are satisfied, and hence there exists a C between 0 and 1 such that f dash C is 0. So what is fx? Fx is already a naught n plus 1 x to the power of n plus 1 a1 x to the power of n upon n plus a2 n minus 1 x to the power of n minus 1 up to so and so forth a n minus 1 x square upon 2 plus a n x. Now f dash x is a naught, this is n plus 1, and the differentiation of this is n plus 1 and xn plus a1n, differentiation of this is nx n minus 1. Now the last differentiation, this differentiation is up to a n minus 1 into 2x upon 2 plus a n. This cancels, this cancels, all this cancels. So what you are left with, f dash x is a naught x to the power of n plus a1 x to the power of n minus 1 up to so and so forth, a n minus 1 x plus a n. Now f dash c is 0, f dash c is 0. Therefore, there is at least this c is 0. So, and the c is the root of this, because f dash c is 0 implies a naught xn, x naught cn plus a1 cn minus 1 up to so and so forth, a n minus 1 c plus a n is 0, because f dash c is 0. Therefore, there exists c belonging to c belonging to, therefore c belonging to 0 1 is a root of a naught x to the power of n. This is actually c. Wait a minute. This is c. X to the power of n plus a1 x to the power of n minus 1 up to so and so forth, a n minus 1 plus a n equal to 0. See the root of this polynomial. This only I had to prove. Next is a good question. This is also a good question. Let us see this question. Yes. Show that, let us write down. Let us take some more space. Let us take some more space. Here it is, question. Let me take more. Wait. Yes. Let us take this question. Show that there exists no real number, there exists, this is no real number, number k for which x cube minus 3x plus k equal to 0 has two distinct root, distinct root in 0 1. Suppose we consider answer. Suppose alpha and beta belonging to 0 1 are roots of fx equal to x cube minus 3x plus k. Suppose that means f of alpha is 0 and f of beta is also 0. जैसे अल्फा बीटा रूट है, इसके कारण f of alpha भी 0 होगा, f of beta भी 0 होगा. Let me rewrite. फिर से लिखते हैं, f of alpha is 0 and f of beta is also 0. Now this is a polynomial, is continuous, it's derivable in between 0 and 1. Let us do it. Number 1 point. Fx is polynomial, so derivable, so continuous, first continuous on 0 1. Second, fx is derivable on open interval 0 1. We just proved, हमने अभी देखा, f of alpha equal to f of beta equal to 0. All the three conditions satisfied. The c between this, I should say, fx is a polynomial derivable on this. I should not take 0 1. I should take here alpha beta. I should take alpha beta. This is alpha, this is beta, this is alpha, this is beta. Open interval alpha beta, such that f dash c is equal to 0. Now fx, now listen one thing. 0, before I make you understand this question, Alpha and beta are in between 0 and 1. So let's understand this. 0 is alpha. So C, this is alpha, this is some C here, this is some beta, and this is less than 1. This is the interval 0 to 1. This is the interval 0 to 1. We may write this much only. We can write this much also, less than equal to here and less than equal to here. But I'm taking an alpha and beta between 0 and 1. That's the main point. We're taking a subset of this, basically. Proper subset rather. I'm taking a proper subset, less than this and less than this. So this condition is must. This condition is necessary. ये condition समझना जरूरी है. हमने क्या लिया? Alpha beta 0 और 1 के बीच में लिया. अल्फा बीटा 0 और 1 नहीं है. अल्फा बीटा 0 और 1 के बीच में है. अल्फा बीटा is in between 0 and 1, but alpha is not 0 and beta is not 1. So f dash x, fx is how much? Fx is 3x square. Fx is 3x x cube. Fx is x cube minus 3x plus k. So f dash x is 3x square minus 3, and this is the thing, as f dash c is 0. So 3c square minus 3 is 0, implies c square minus 1 is 0. C is plus under root of 1 and c is plus minus 1. So beta is not 1, does not belong to open interval alpha beta, because beta is not 1, alpha is also not. Now 1 रहेगा ना minus 1 तो होगा ही नहीं, 0 के ऊपर है. Minus 1 will not take place because it is greater than 0, and 1 will not take place because beta is less than 1, because beta is less than 1. So 1 is also not possible. So hence our assumption that there are two roots are wrong. Two real roots. There is a root. Hence our what assumption did we take? There is a real root. We took that k, there is a real root. Here you see, what was the question? So that has a real number k, so that there exists no real number k for which has two distinct real roots. So you see, I am not getting two distinct real roots. There is a c, I am not getting this two distinct real roots here. I have taken, what I have taken, that there is a real root. There is a, see, I have taken two distinct real roots, basically. See, this I have taken. I have taken two distinct real roots. I have taken. See, I have taken two distinct real roots, and I had to show there is no real root number k for which this number, because of this number, I will not get any distinct real roots. Two distinct real roots. देखो, कहने का मतलब ये है, मुझे ऐसा कोई k नहीं मिलेगा जिसके कारण मुझे इस इक्वेशन का दो रियल रूट मिले, डिस्टिंक्ट रियल रूट. रियल रूट नहीं, डिस्टिंक्ट. तो मैंने क्या माना? See, the idea is, for this particular value, wait a minute, sorry, for this particular value of k, this equation, this whole equation, for any value of k, I should say, for any value of k, I have to show that it has no distinct real roots. Let's repeat that point. For any value of k, I will not get two distinct real roots. That's the main idea. किसी भी value of k के लिए मुझे दो distinct roots नहीं मिलेंगे. For any value of k, this whole question means that for any value, for any value of k, कोई भी value of k के लिए मुझे distinct roots नहीं मिलेंगे. I will not get distinct roots for any value of k. So I have, wait a minute. So I have considered two distinct roots, and I found a contradiction here. I found a contradiction here. You see, I found a contradiction here. I found a contradiction here. That's the main problem. So it has no distinct, there is no number k. There is no number k for which it has two distinct real roots. So there does not exist a k belonging to R such that fx, such that, wait a minute, such that fx fx equal to x cube minus 3x plus k has two distinct roots, two distinct, distinct, distinct roots. Let us understand again this question. Question is saying, the question is saying that for any value of k, I will not find two distinct roots. For any value of k, any value, and that k must be a real number. That k must be a real number. For any real number k, I will not get two distinct roots. That's what I want to show. So what I have taken by contradiction, by the other way around, by contradiction, I'm trying to prove it. I have taken two distinct roots, alpha and beta. They are very much distinct. And what I have come at? I have come at a contradiction. And therefore, there is no k. This means there does not exist. This means there does not exist. Any k belonging to R has two distinct roots. Rather, I should write two distinct real roots. Roots. Okay, real roots, because we are being real numbers. Even if you write roots, no problem. In this case, देखो क्वेश्चन में ये बहुत अच्छा क्वेश्चन है। मुझे ऐसा कोई की नहीं मिलेगा जिसके कारण इस इक्वेशन के दो रूट बन जाएंगे। मैंने क्या किया, बाय कॉन्ट्रडिक्शन से दो रूट मैंने मान लिए। ये दो रूट मानते ही, डिस्टिंक्ट रूट मानते ही मुझे क्या मिला? मुझे मिला एक कॉन्ट्रडिक्शन। मुझे यहाँ पे एक कॉन्ट्रडिक्शन मिला। तो इसके मतलब ऐसा कोई भी के नहीं बनेगा।